Welcome to Math 20-1. We are using the Pre-Calculus 11 book, Chapter 1, Sequences and Series, and today is topic 1.1, Arithmetic Sequences. Let's get started. Sequences. A sequence is an ordered list of objects that contains elements or terms that follow a pattern or rule to determine the next term in the sequence. The terms of a sequence are labeled according to their position in the sequence. That means that the first term in the sequence is called T1 or term 1. The number of terms in the sequence is n, some value of n we don't know, and the general term of the sequence is called Tn, term n. This term is dependent on the value of n. Finite and infinite sequences. A finite sequence always has a finite number of terms. For example, the sequence 2, 5, 8, 11, and 14. Or another example would be 5, 10, 15, 20, and following the same pattern all the way to 100. An infinite sequence has an infinite number of terms. Every term is followed by a new term. For example, 5, 10, 15, 20, and continues on forever. An arithmetic sequence is an ordered list of terms in which the difference between consecutive terms is constant. In other words, the same value or variable is added to each term to create the next term. This constant is called the common difference. If you subtract the first term and the second term from the second term, or any two consecutive terms for that matter, you will arrive at the common difference. The formula for the general term, which helps you find the terms of a sequence. This formula is a rule that shows how the value of Tn depends upon the value of n. Let's examine the sequence 10, 16, 22, 28, and goes on forever. This would be an infinite sequence. Let's look at the terms, the sequence you expressed using the first term and the common difference and the general sequence. So we're going to make a chart. Term 1 is going to be 10. Term 2, 16. Term 3, 22. Term 4, 28, and we can keep going. The sequence using the first term and the common difference. Well, the first term would just be 10. The second term would be 10, and then the common difference is going to be 16 minus 10, or 6. So we can express term 2 as 10 plus 6. Term 3 would be 10 plus 6 plus 6, or, that's okay, we'll leave it like that. And term 4 is 10 plus 6 plus 6 plus 6 again. So the general sequence, we're going to say that's term 1 is term 1. Term 2 is term 1 plus the common difference. Term 3 is going to be term 1 plus 2 times the common difference. And then term 4 is going to be term 1 plus 3 times the common difference. Now I think we can come up with a general term. So the general arithmetic sequence is Tn is going to be term 1, term n, the general term is going to be term 1 plus n minus 1 times the common difference. So the general term of arithmetic sequence is referred to as Tn, T sub n, or Tn, is equal to T1, term 1, plus n minus 1 times the common difference. And the common difference is defined by simply term 2 minus term 1. Moving on to example 1. Determine a particular term. A visual and performing arts group wants to hire a community events leader. The person will be paid $12 an hour for the first hour of work, and $19 for 2 hours of work, $26 for 3 hours of work, and so on. Write the general term that you would use to determine the pay for any number of hours worked. And what will the person get paid for 6 hours of work? Here we go. Starting out, to find the general term, we start by making a list of the terms and finding a common difference. T1 is 12, term 2 is 19, term 3 is 26. Term 4 was 33. Because the common difference is 19 minus 12 is equal to 7, we can say that the general term is going to be Tn is term 1, which is 12, plus n minus 1, which is going to be the common difference of 7 times n minus 1, and that's 12 plus 7n minus 7. Simplified form would give me common term Tn is equal to 7n plus 5. That's going to be our general term for this sequence. B. What will the person get paid for 6 hours of work? All we're going to do now is plug that into our general term, and you're going to say T6 is going to be our 6th term, is 7 times 6 plus the 5 is going to be $47. For 6 hours of work, he will get paid $47. Here in example 2, we're going to try to determine the number of terms. The muskox and the caribou of northern Canada are hoofed mammals that survived the Pleistocene era, which ended 10,000 years ago. In 1955, the Banks Island muskox population was approximately 9,250 animals. Suppose that in subsequent years, the growth of the muskox population generated an arithmetic sequence in which the number of muskox increased by approximately 1,650 each year. How many years would it take for the muskox population to reach 100,000? Well, first of all, term 1, starting in 1955, is 9,250. Term 2, well, we're told that the common difference was 1,650. So that means I can add 1,650 and get term 2 of 10,900. Term 3 would be 12,550. Term 4 is 14,200. Now, the arithmetic sequence, there it is going to be all the way up to ending at 100,000. Since term 1 is 9,250 and D is equal to 1650, Tn can be written as, or the last term, sorry, is 100,000. The general term, Tn, which is also called Tn, the general term is T1 plus n minus 1 times D. So what we want to do is we want to plug all the numbers in and solve for D. So we can say Tn is 100,000, that's the last term, equals the first term, 9,250, plus n minus 1 times the common difference of 1650. Expanding and multiplying will tell us n, how many terms it's going to take to get us there. 9,250 plus 1650n minus 1650 is going to clean up to 1650n plus 7,600. Now I can subtract 7,600 from both sides and divide both sides by 1650, and n is equal to 56. That means it would take 56 years for the muskox population to reach 100,000. In example 3, we're going to determine the first term, how many terms, and n. Jonathan has a part-time job at a local grocery store. He's been asked to create a display of cereal boxes. The top 6 rows of his display are shown. The number of boxes in the rows produced an arithmetic sequence. There are 16 boxes in the 3rd row from the bottom and 6 boxes in the 8th row from the bottom. How many boxes are in the bottom row? Determine the general term, Tn, for the sequence, and what is the number of rows of boxes in his display? Well, from the bottom to the top, the number of boxes decreases by 2 each row. So we know that D is going to be negative 2 because it decreases by 2 as we goes up. There are 16 boxes in the 3rd row from the bottom. Therefore, we can substitute all this information into our general formula. Tn is equal to T1 plus n minus 1 times D. Now, 16 is equal to term 1 plus 3 minus 1, because it's the 3rd row from the bottom, times the common difference, which is negative 2. And if we clean all this up, you're going to find that term 1 is going to equal 20. Okay, we have 20 boxes in the bottom row. For B, the general term, Tn, is equal to T1 plus n minus 1 times D. I think we know all the information now. Since we know the first term is 20, and n minus 1 times negative 2 for D, it's going to be 20 minus 2n plus 2, or negative 2n plus 22. That's going to be our general term. Lastly, the number of rows, Tn is equal to negative 2n plus 22. The last row has 2, so you can say 2 is equal to negative 2n plus 22. Subtract 22 from both sides, and then divide both sides by negative 2, and it tells us that n is equal to 10, meaning that there are 10 rows of boxes. Okay, our last example, generating a sequence. A furnace technician charges $65 for making a house call, plus $42 per hour or portion of an hour. Generate the possible charges. So for 1 hour, we're going to say that's term 1. That would be 65 plus 42, or is 107. Term 2 is $149. Term 3 is $191. Term 4 is $233. So now we can subtract those two to find our common difference is 42. And Tn is going to be T1 plus n minus 1 times D. And since that's 107 plus n minus 1 times 42, we can expand it and simplify it to find that Tn is equal to 42n plus 65. For B, what is the charge for 10 hours? Well, for 10 hours, you simply substitute 10 in for n, and you're going to get 42 times 60 n, 42 times 10 plus 65, or $485. So your assignment is to do page 16, numbers 1 to 11.